Hi everyone, my name is Adrian Cockcroft. Today I'm going to talk about adding sustainability concerns to development and operations. I'm calling this DevSusOps, and I have the Twitter handle to prove it. You can follow me at AdrianCO or at DevSusOps to follow up with any questions you might have around this. This is part of the QCon San Francisco Green Tech track. I'm opening the track and I'm going to talk about a few more things. The Green track after this talk consists of a more operational view of how to optimize from the Cloud Carbon Footprint tool, a more developer-oriented viewpoint, moving from Java to Rust to save energy, to optimize all the code you write, and a talk from Tesla talking about their virtual power plant and how to actually build interesting applications. What does it take to build a virtual power plant, all the software and systems behind that. Then we'll have a panel session with speakers from each of the talks, and at the end there's an open space so we can have other discussions. I'll be here all day. So, why does sustainability matter? You may have various different thoughts about this, but I think I've got most of them here. The definition of sustainability is really around leaving the world habitable for future generations. That's sort of the essence of the United Nations definition of sustainability. But the reason it matters to most companies is regulatory compliance. What we're seeing is a lot of, particularly in Europe, the regulators are saying you've got to measure and report your carbon footprint and other sustainability risks. And in the US, we're moving in that same direction, and around the world, wherever you are, you've got regulations saying you're going to have to figure out what is the sustainability posture of your organization. Then there's market transition risks. If you think of companies that say own gas stations or make parts for gas-driven cars, that market is transitioning to electric cars. So that's a market transition. If you own a coal-fired power station, you're in a market transition. And so it's any time that the market is changing as a result of the transition to a more sustainable future, you have a market transition risk if you're selling products that are affected by that market transition. Then there's physical risks to business assets. If you own property at sea level, in very high temperature areas where it's getting hotter and hotter outside, you try to move freight down rivers that are drying up, or there's all kinds of physical risks that you might have. Sea level rise is one that's affecting the coast, but there's a lot of weather and high temperature related physical risks to business assets from climate change. The other thing that you may have is products which are branded in some way to be green. And so the market positioning, you need to stand behind them and walk the talk and actually build green products in a green way. One thing that you can't really underestimate, I think, is employee enthusiasm. Many of us have children that come home from school and say, "What are you doing to save the world so that I have something to live in?" That's a big motivator. And a lot of people, I'm a little older, but my kids are grown up, but I'm, it really matters what are we doing for the future, and there's a lot of personal investment in this, way beyond what you'd expect for just say a cost optimization exercise. People get much more invested and excited about a carbon optimization exercise. As we move into a more sustainable future, we're actually starting to see costs come down either now or you're seeing future cost reductions. Like the cost of renewable energy is now lower than the cost of fossil fuels. Fossil-based electricity. So we've got current payback right now. The cost of operation of an electric car is less than the operation of a gas car now, although the upfront price is still a little more. So over time, you see in the future, we'll see electric cars being cheaper than gas-powered cars even to buy in the beginning. And then for some organizations who've got a bad history of working in climate change, like fossil fuel companies, they're concerned about the social license to operate. Are people still going to want to go and work there, want to buy products for them if they've got a bad reputation around sustainability? So what can we do about it as developers and operations people? So on the development side, we can optimize our code, choose faster languages and runtimes, pick more efficient algorithms, use faster implementations of those algorithms, things like SIMD JSON, for example. It's a super fast way of processing JSON. Reduce the amount of logging we do, and then reduce retries and work amplification by getting our retry algorithms worked out. That reduces the overall workload. So that's on the developer side, the way you set up your application. And then, on the operations side, whether you're a DevOps engineer doing development and operating it, and you run what you wrote, or whether there's a separate ops team, there are more operational concerns. You want to run the code you've built at a higher utilization. That might require tuning the code so that it can run at high utilization, but you want to run at high utilization. You want to use a lot of automation for things like auto scaling. You want to relax any over-specified requirements you may have, push back on things that look either expensive or high carbon, and say, do we really need to have retained data for forever, right? So you might want to archive and delete data sooner, deduplicate data. And then the thing that's really you don't normally think about is choose times and locations carefully. If you run something at midday, there's a lot of excess solar capacity. The grid is very green. If you run stuff at midnight, then you've got a lot more fossil fuel in the mix. So that's really the time-based thing, and then location. Some locations, say if you run things in France, there's lots of nuclear energy. It's a very clean grid from a point of view of carbon emissions. If you run things in say Singapore, there's a lot of carbon in the grid there, so you end up with a very high carbon location. So you go pick those things. Those are things that we'll talk a bit about later, but are not the sort of normal concerns. And almost all of these things are directionally the same as saving dollars. So if you just make your system more efficient, you're saving money as well as saving carbon. I say almost all cases because there are a few situations where you might say some regions which have lower carbon may cost a little more than other regions if you look at a cloud provider. So migrating a workload, you might spend a little bit more but reduce carbon. That's one of the few corner cases that you might see. The main thing is, even though you've got directionally saving money saves carbon, but the actual amount of carbon per dollar varies a lot. So you have to understand whether saving a dollar of compute or a dollar of storage or a dollar of a service, what's the carbon impact of that? So I'm going to spend most of this talk focusing on how to measure carbon and see if I can figure out how to get the right mental models into your heads about how to think about it, the terminology, the way these things operate, so you can figure out in your own work how to measure carbon, how to work in this space. So we're used to reporting and optimizing throughput, latency, utilization, capacity. We've started adding cost optimization to those kinds of things. And carbon is really just another metric for monitoring tools to report. And we're starting to see a few monitoring tools with carbon as a metric within them. But what we're really seeing is regulators and market pressure causing companies to have to report carbon and decarbonize their products and services. And these are two separate things. Reporting carbon is something that the board has to do a report and sign off, and auditors come in, and every quarter you do a financial statement. You're going to have to put carbon in that financial statement alongside the financial numbers in the future. Those are audited numbers. What you need to do that is a little different than what it actually, the information you need to decarbonize products and services. So do you know, anyone in the audience, do you know how much carbon your company emits for, let's call it, data processing and hosting per year? Most people don't really know. But how can we get to an answer? So what you may know is your company budget is like, what's your IT budget? Most people have some idea whether it's, a million, 10 million, or 100 million, or whatever. It's somewhere in that ballpark, right? And what you can do is for every $1 million you spend on, say, IT, or whatever you define as data processing and hosting, it's 159 metric tons of CO2. That's the economic model. So that's just a rule of thumb you can do. If we've got a $10 million budget, we're probably doing, 1,000 to 2,000 metric tons of carbon. You're in that kind of range. So where does that number come from? So if you go and search for carbon factors, you'll find places like this, climatic.io. You can go on this website, you can search, and you can find that there is a standard number which is provided by the EPA. So this is a government provided number for 2020. So if you are operating, you're doing your carbon report for 2020, you go to the EPA number and you find it's 0.159 kilograms per dollar, which is the same as 159 tons per $1 million. You also notice this is calculated from 2016 data, which is a bit worrying. It's a little bit out of date, but also that it includes the entire supply chain, cradle to shelf, meaning all of the materials used to make it, as well as the energy used to operate it, all the way through. Right. So this is quite an interesting number, but it's a very average number for the entire industry. So if you have nothing else, you use this number. So the economic model for carbon, basically, you take your financial report, you break down the spend categories, find the right emissions factor, multiply and accumulate. So the good thing about this is really everybody uses these models. Most of the carbon numbers you see out there that people are reporting are largely based on economic models. It's just the way the world is. It gives you a big picture, approximate view. You can always get the input data. The industry standard emissions factors are available. Some of them are openly available. There are some where you might license them to get some more specific ones. Auditors can trace the calculations easily, and it does estimate the entire life cycle. So that's the good. The bad is it's a really coarse model. Some of the factors are based on old data, and fast-moving areas like IT, they may not be that accurate. It can be hard to actually pick the right factor, and this is one of the hardest things, is finding how do you categorize things and pick the right factor. It's not trivial. And then this other problem is that if you spend more, let's say you go and you buy some green product because it's greener, but you spent more on it. And if you don't account for, if you don't have a different factor for it, then your reported carbon will go up just because you're spending more. So effectively, carbon optimizations have no effect. And the ugly thing here is if you do this for 1 year, economic model, and then you come up with a more accurate measure the next year, it could be quite a lot higher. So recommendation here, start here, use spend when no other data is available, use economic models to figure out where to focus efforts. And if you look at your entire business, you're going to see what do you work on? Are you working for a SaaS provider or a bank where almost all your costs are people and IT and office buildings? Right. In that case, maybe most of your carbon footprint is IT. If you're, and I did a talk with Starbucks earlier this year, or late last year, there was most of their carbon footprint is dairy, it's milk. Their IT component is a very small piece. So if they can use a little bit more IT to use that to convince people to maybe use oat milk instead of dairy, that actually makes a bigger difference. Like a small percentage change in Starbucks as end users from dairy to real milk to oat milk will actually make more difference than their entire IT budget. So you have to think about, what is the real carbon footprint of your company? Don't just focus on the IT component. So I'm going to now explain something called the scopes of carbon with some slides I made a year or two ago while I was at AWS. So the first thing is the fuel you consume. And this is you count whoever owns the fuel when it's being burnt, right? So the fuel, you buy gas, you put it in your car, you drive it around, that you are now doing scope 1 emissions for whatever you put in the car. Anything you burn in your fireplace or gas used to heat your home, anything used for cooking, that's scope 1. And the way to get rid of scope 1 is to electrify everything and then move on and then figure out how to get renewable electricity. Scope 2 is really the energy used. And so this is the energy where it's consumed, but you're not burning the fuel yourself. Somebody else burnt the fuel, sent you electricity. So you have the grid mix, which is the mix of power, which is either renewable or fossil fuel. I mean, you could break it down, but those are the two main categories. What you want is carbon emitting and non-carbon emitting. So nuclear is good because it doesn't emit carbon. right? So we'll include nuclear. Nuclear isn't really renewable, but it counts as zero carbon. So that's kind of the way you look at the grid mix. And then you look at your location, say your house. You've got a heat pump, solar panels, batteries, electric car. You've managed to convert that house to be all electric. And then if you can run the house off the batteries and the solar panels, you're basically getting your scope 2 to be very low carbon. And then if you're doing cooking, you should switch to induction and electric cooking, because also gas ranges cause pollution and things like that. So some of the benefits aren't just carbon. There's other things that make it better to move off of fossil fuels. Scope 3 is where it gets really complicated, depends an enormous amount on what kind of business you're in. It's your supply chain. So the point here is that, say you had part of your business that was emitting a lot of carbon, and you said, well, I'm just going to buy that as a service from somebody else so I don't have to count that as my carbon. Well, that's part of your scope 3, so you can't get out of your carbon emissions by just offshoring it and sending it out and pushing it out to suppliers and say, well, I don't own this thing. So any business that you don't own, which is supply chain, and also the cost your consumers, the carbon your consumers emit to use your product, also can count. And in some cases, the inventory, the things you own, those things count as scope 3 as well. So think about this as pretty complex and extremely dependent on what kind of business you're in. If we look back at data centers, really the only scope 1 you'll see in a data center environment is a backup generator. And they run diesel mostly. What we're doing to decarbonize those is put in larger and larger battery packs, so the diesel is really a secondary backup, doesn't get used very often, and also move to biodiesel and fuel cells and other things like that, which can be fed by cleaner data sources, cleaner energy sources. So it's possible to work on that, but it's a tiny component of data center energy. Backup generators really don't run that often. As I mentioned, scope 2 is this mix of electricity sources coming into the building. And for a data center, scope 3 will be the building itself, the racks and coming in, all of the things, anything used to deliver the components to physically put up the building. That's all going to be your scope 3. If you look inside a data center, you can see there's cooling, power distribution, heat. There's a lot more going on there. We'll look into that a bit more later. So ultimately, your suppliers need to report scope 1, 2, and 3 to you, and then you need to report scope 1, 2, and 3 to your consumers. And this is all defined by the Greenhouse Gas Protocol, and you can have many happy hours reading this website to figure out for your particular kind of business what you have to do. So we've talked so far about the economic models, just using financial data to feed the carbon data. So if we want to get a bit more accurate, what we need is a process model, where the units are the materials you're using or the kilowatts of energy you're using. So the process model, you measure the materials, you find the right emissions factor, multiply and accumulate. For example, diesel and gasoline will have different, and jet fuel will have different emissions factors, right? Even though they're all measured in gallons or kilograms or whatever. So what you end up finding is that this is called a life cycle analysis. That's what that cradle to shelf component of that metric I highlighted earlier was talking about. And what you really want to do is look at manufacture and delivery, which is your supply chain, your energy, which is your use phase, and then what do you do once you're done with it? How do you dispose of it? Do you recycle it? What's the energy consumed there as well? So the good thing about these models, they exist. It's a well-defined methodology. LCA has standards around it. People are trained in it. You can hire people or consult with people that can generate these models. They're reasonably detailed and accurate. Particularly for the use phase, energy data is fairly easy to get. And when you do an optimization, it really does reduce the reported carbon. So you're in the right area, and auditors can trace those calculations. The bad thing is models are really averages for a business process. This is not going to tell you the actual carbon emitted by one machine in your data center running one workload. It's going to give you an average for the whole thing. It's still quite a lot of work to build an LCA model. It may be more expensive than you'd want to spend to hire the right people to do it. The supply chain and recycled data is particularly hard to get, and quite often people build these models and they just do the energy part and they don't think about the scope 3 part, or they just don't get to it because it was hard. Then they just report carbon. So the ugly part here is some people just really focusing on energy use and report, well, we're green because we're 100% green energy, and then get surprised when say, yeah, but all of that hardware you're using emitted an enormous amount of carbon when it was being made, and you have to count that too. Okay, so what you should do is use the economic models to tell you where most of your carbon is, then build process models for those. Start with energy, but don't forget the rest of the life cycle. So how hard can it be to figure out how much carbon is coming out of a workload? Here's sort of a zoomed in look at that data center. You get grid mix from your local utility bill, which you usually get a month or so after you've used the electricity. Uh, that's kind of annoying because means you don't know what today's energy mix is. You just know what last month's was. And then there's power purchase agreements or renewable energy credit purchases, which I'll explain a bit later, which is basically affecting your grid mix. And then you have power usage efficiency, which accounts for losses and cooling overhead as the power that comes into the building is delivered to the rack. So the machine may use a kilowatt, but there might be, say, 10% extra energy which went to the cooling and distribution area. So 1.1 kilowatts had to come into the building to provide that energy. So scope 2 carbon is going to be the power mix multiplied by the PUE multiplied by how much capacity you use, and then the emissions factor per capacity. So the amount of CPU you used or storage, and then you'd have a different emissions factor for CPUs and storage of different types, networking, whatever. So a few problems here. First of all, these utility bills are going to be a month or more late. The further you get in the developing world, the harder it is to get this data and the more delayed it's likely to be. And then I mentioned power purchase agreements. These are contracts to build and consume power generation capacity. So Amazon has over 15 gigawatts of these. So basically, Amazon contracts with somebody else to say, we're going to give you some money and you're going to build a wind farm or a solar farm, and we're going to buy the energy from that farm at a certain price, usually lower than the typical price that you'd get if you just went to, say, PG&E and say, PG&E is whatever it is, 20-something cents per kilowatt hour. You could get much less than that if you build your own solar. So it saves money, and you're funding the creation of a new solar, wind, or battery plant that would not otherwise exist by entering into this contract. So this is good because it's what's driving a lot of the rollout of solar, wind, and battery around the world. Now, if you just sort of fund building your own solar array or wind farm, and you're just selling that capacity to PG&E or to whoever comes by, one of the things you can do is sell additional the fact that it's renewable. You can charge a little surcharge to say this is renewable energy, and I'm going to allocate that to somebody. So companies can go and say, I want to buy some renewable energy credits, and they're going to get used once. So once everyone's bought all the credits for all of the solar that's kicking around in the market, you're out, right? So there's only a certain amount of this capacity available because it's the open market for otherwise unused power. So it's not quite as good as a PPA, but it's still good. You're still, funding somebody with a bit of extra money for the fact that they built a solar farm, and it makes them more profitable, and it means that, ultimately more solar farms get built or whatever, right? But it's not as direct as a PPA. And what typically happens is companies do PPAs, as many PPAs as they can. Once they've got all of those in place and this is, okay, we've done everything we can possibly do, we have a bit more money, we'll buy a few RECs on the side. It's a much smaller proportion than the PPAs for the large cloud vendors. But you're buying a few RECs to just top it up and sort of, help things out. All right. So the grid mix itself, another problem. It's not constant. It's going to change every month. So whenever you look at a carbon number, you have to say, when was that carbon number? Right? There isn't just a carbon number. You have to say, was that in what year, what month, even down to what hour was it? because now we're starting to see hourly 24/7 grid mix coming from some suppliers in some parts of the world. This is going to take a long time to get around everywhere. GCP, Google really started driving in on this. Azure are working on it. AWS have not said anything about it yet, but hopefully working towards it. And there's also a company called FlexiDAO working in this area. You could go look at what they're doing. They're working with GCP and Azure and other people. And one of the problems here is that the Cloud Carbon Footprint tool doesn't include PPAs. It really only runs off the public grid mix. It can't really know how much you get from the PPA because that's private information that isn't shared. So it's all difficult. If we look at PUE, not well standardized. The different architectures of different data centers mean that you can come up with differences that really aren't comparable. Like, do you have a centralized power distribution system or a distributed one? Are you delivering high voltage AC or DC all the way to the racks? Do you have your batteries in every rack or centralized? It actually makes a difference to the way PUE is calculated, how you do that. Lots of discussion about that in this blog post. Now, if you look at the capacity, dedicated capacity is relatively easy to account for, maybe in a data center environment, but once you get into the cloud, it's really hard to figure out how much you're using of a shared service, network equipment, slices of instances, virtual machines. Really tricky. You can get roughly in the right ballpark, and those are the factors we've got, but you can't really know what you're doing. And then there's this other problem. If you're operating a multi-tenant service and want to report the carbon to your customers, then you have a problem figuring out how much capacity to allocate to each customer, how much is overhead that you should own yourself. And this AWS is having to solve this. All the cloud vendors basically are having to solve this problem for their customers, and all of the SaaS providers running on the cloud are then having to do it downstream. And then we get to the emissions factor per capacity. You need to know how much power every instance type, storage class, or service uses. Depends on utilization, overheads. It's actually very difficult to figure this out. You can get some averages. There's some data for some systems, but in the cloud providers sort of roll all this up, and some provide some estimates, but it's all of these things are estimates that are in roughly the right ballpark is probably what you'll get. Like, I wouldn't worry about if you get a number for an instance that looks vaguely similar on one cloud provider to another cloud provider. I'd just use the same number for the emissions factor. Okay, so if you're going to report carbon and it's going to be reviewed by the board and the auditors and all this kind of stuff, you really need to be using the cloud vendor reports. That's kind of what AWS and Azure and Google have, those kinds of reports available. And if you're on-prem, you need to use economic models probably, or build your own models. The data, auditable data, has to be traceable and defensible, but as I mentioned, it's too coarse and it arrives too late to be useful for optimization. And then on top of that, there's two different ways of reporting carbon. So I'm going to try and explain the difference between location and market-based metrics. So if we look at the location base, this looks at a particular building and it says what is happening at this building. There's the grid mix coming in. If I use an incremental extra kilowatt hour of energy, how much additional incremental carbon will be consumed supplying me that extra incremental kilowatt hour of energy? That's the idea for location based, and it comes up with higher numbers for carbon than the market based method, and it's typically what's happening. The Google data, the hourly 24/7 data is sort of based on this. The problem with it is that the way it's defined, it does not take into account the power purchase agreements, which the cloud vendors are spending an enormous amount of money on. So what's used in that case is a market-based method that says all of the electricity in a market is all the same. You pump electricity, you push electrons into the grid, they pop out of the grid. If I have 100 megawatts I'm putting into the grid from this power station here, I can use it over here and it's fine. It just flows through the grid. And I want to take into account the fact that I am generating this power and it's my power and I've got the PPA or the REC in place. So the market-based method includes the PPAs and the RECs. And you effectively are creating a custom grid mix for your data centers, and it's usually averaged over a month. So the reason this matters is that basically your AWS and Azure data is regional market-based, and they take into account PPA generation and RECs that are within the same grid, so that electricity flows together. Google's had a claim since 2017 that said that they generate more energy than they use, and they're taking that on a global basis, which is a bit dodgy, really, because they were basically saying we generate more power than we use in the year, but they were basically over-generating extra power in USA and Europe and saying that's good, but Singapore, you're still emitting a lot of coal-powered and oil-powered fossil fuel generation. So they were saying on average across the whole world it made sense, but it doesn't really. You really want to be, it makes sense if you do it at the regional market level where the grid is connected. But then Google went to this sort of more current data is location-based API and 24/7, their API work. You can't compare the numbers between AWS, Azure, and Google because of this, but the Google data is more useful for tuning work, and their API is really the most useful API if you're trying to build some tooling on this right now. And over time, as the utility grid decarbonizes, it matters less. So, if you're in France where it's almost a completely carbon-free grid, it really doesn't make much difference. It'll make a bigger difference if you're in Asia. So what can you do today? For workload optimization, we need directional and proportional guidance. So the Cloud Carbon Footprint tool up next is open source, uses billing data as input, maintains a set of reasonable estimates or guesses for carbon factors, but your mileage will vary as to the actual data you get out of that. I wouldn't put it in an auditable report, but it's useful for tuning. The Green Software Foundation has come up with a software carbon intensity standard. This is a model for reporting software impacts per business operation, like grams of carbon per transaction or per page view or whatever, and they're defining that standard. So it's worth going to look at that. And AWS has the well-architected pillar for sustainability, which I helped write and get out about a year ago. It's the guidance on how to optimize development operations for carbon. So some good advice in there. So just to wrap up, where's all this going to be in a few years' time? I think most monitoring tools are going to report carbon as the data becomes more available. Eventually, all the cloud providers are going to have detailed metrics. I think Google's got detailed metrics now. Microsoft has some if you know where to look. AWS really doesn't have detailed metrics at this point, but I think we're all going to get there. And then the Europe and US cloud regions are pretty close to zero carbon now if you take the PPAs into account. There's a lot of generation offsetting the energy used. Asia everyone has the same problems, and the Asian regions probably in the next few years are going to get to zero carbon. It's just regionally been very difficult to get solar and wind projects in place. So any questions you have, happy to discuss it now or later, or you can DM me or send me messages on Twitter. And that's what I've got. Thanks very much.
Hi, Adrian.
Hi there.
Great presentation and on a very timely topic. Probably the biggest challenge of our generation, the biggest challenge that the society is facing these days. We only have 9 minutes for questions. We haven't had any audience questions yet, but I have a few questions that came to my mind watching your presentation. So one of them has to do about resources that people can use to follow up. You mentioned some websites. Is there any literature, like how we have the definitive books for performance, for scaling? Is there any book about this topic yet?
I think the I think the best place to look right now is the well-architected guide that AWS put out, and more recently, the Microsoft has also put out a well-architected guide for Azure. The Microsoft one is based off of the Green Software Foundation recommendations, which are very similar. These are all very, very close. But people are basically looking up the same things. There's some references to uh, some of the way to think about it. And there's obviously stuff that's specific to particular environments, like some cloud vendors like AWS have Graviton processors that use less power. Um, Also, I recently noticed that AWS is now listing the regions that have 95% or better clean energy, which are basically what I said. It's Europe and Asia. So Europe and US are better than 95% for 2021. Right, and it's been improving since then. But the Asia regions are not included in that list. So they've actually, if you go to the Amazon sustainability, if you just go to Amazon's website and search for sustainability, there's a section there about cloud. And I tweeted this a few days ago on Mastodon, or tweeted it, I guess, nowadays we're doing. So, so pretty much, as I was saying in the talk, if you're worried about the energy use of your system, you should be worrying about the energy use, any energy use you have in the Asian regions, or outside Europe and Europe and the US. There's some other Africa and whatever, and Arabian ones, which are not on that list at this point. But over time, the number of regions that are 95% or better green is going to go up, right? So that's kind of the way. By 2025, the goal is to have everything at 100%. So that's what AWS is doing in terms of sort of, you can go get data off their website. The Green Software Foundation's collecting useful data and making sense of it. And then I'm just looking around for really efficient libraries. Things like SIMD.json, which was mentioned in the Slack channel. It's a good reference there. The Z standard compression algorithm saves you about 30% on your capacity, on stored capacity, and is more efficient on reading data back, decompressing in particular. There's a sort algorithm that Google came out with recently and posted that's built a little bit like SIMD.json. It's just the fastest possible implementation of quicksort or whatever, right? If you want to sort things. So rather than using the languages that are in your environment, just go and go the default languages, the default libraries in your language. Maybe sort of look for some more efficient ones for key things that you use a lot.
Got it. And I guess to some extent, for these things to matter, there needs to be more of an organizational change towards practices like that. And I believe a question that frequently comes up when we talk about sustainability is how can an engineer or a technical leader, either in their team or as part of a larger organization, convince that organization to adopt more sustainable practices. Have you seen any ways that can help with that transition?
Yeah, I talked about that at the beginning. The board coming on down with regulatory, you're going to have management saying, "Hey, we need to figure out how to measure and optimize this because we got to report it to the street as part of our quarterly numbers." Right. So that's driving it from one end. There's individuals are interested, sort of bottom up, and a bunch of people are going to be building data lakes and trying to gather this data together. And that's a workload which is starting to appear. One of the things, we're in the middle of the AWS reInvent conference, and there's a lot of talks there on sustainability. If you go to YouTube and look at AWS events and just search for sustainability, most of them start with SUS something, sort of SUS 302 and things like that. But there's some good talks there. I was watching some of them last night, trying to catch up on the videos. And some of them are companies talking about how they're measuring their carbon, and then there's some other recommendations in there. So a lot more this year than there was last year. Last year we had sort of 4 or 5 sustainability talks. We had a fairly basic track that I helped organize. This year I'm no longer working at Amazon, but the track has 2 or 3 times as much content in it. So there's a good body of content there. And if you look at the similar events from the Google Cloud and Microsoft, all of the major cloud providers now have a lot of examples and content around sustainability as part of their deployments. And we're really just seeing the efficiency of and the ability to buy green energy is really driving this, and the cloud providers are much more efficient than on-prem. You have to do a lot of work on-prem to get close. So I, that's really, and that work generally hasn't happened, I'd say.
Got it. So Adalberto is asking, do you think cloud providers could open or move operations to countries where clean energy was more available, such as Africa and South America, where the availability of solar and wind energy is greater?
Yeah, they're doing that, but what they're doing is they're putting in solar, wind, and batteries. Like AWS recently launched a region in Spain, but it took quite a long time to get the region up and running. They announced it 2 or 3 years ago, and they immediately put in solar and wind. So the energy environment went in and came online before the region came online. Same thing happened in Melbourne, Australia. The Melbourne region has a lot of local solar and wind solar, and the Sydney region in Australia doesn't. It's got a lot more coal. So you know, it's sort of being done in jointly as the cloud providers are planning their regions and rolling around the world. It takes a while to build a building, takes a while to put up a wind farm. They're doing them all in parallel and all going as fast as they can. Amazon is a little different because it's actually solving for the whole of Amazon, not just for AWS. AWS is a minority of Amazon's energy use. They use a lot more energy in the delivery and the warehouses and that side of the business than they do with AWS. Whereas Google and Microsoft are primarily online businesses with most of their carbon footprint is from IT. So if you look at the totals, Amazon is like about 4 times the carbon footprint of Microsoft and Google, but that isn't AWS. That's primarily the rest of the business. And they're sort of solving for the big picture. And this is one of the things to think about. Don't solve for like your little piece of the picture because you may be sub-optimizing something outside. You've got to kind of take the sort of scope 3 big picture view of like what is the entire environment and how do you solve for less carbon in the atmosphere for everybody rather than making the numbers go down for a particular workload somewhere, right?
Closely related to that, William is asking, do you think there are other perspectives than cloud architecture?
For
I'm
for
not sure if
carbon
he
monitoring,
means thinking about sustainability also in terms of waste, maybe, or
yeah. Oh, sure, yeah. Yeah, so there's energy use is the one that's really driving carbon, which is driving a lot of climate change, climate crisis, right? There's also water. AWS just did an announcement this week about a water commitment to be, I forget the exact commitment, but something like clean water by a certain date everywhere in the world, 100% clean. So a lot of the AWS regions, they take in wastewater that is not suitable for drinking and irrigation, and they process it as part of, they use it for cooling, then they process it before they put it back, and it goes straight into the fields as agricultural water that's cleaned up. So there's examples like that where they do use a lot of water in data centers, and there's another one I think maybe it's Backblaze. They have a data center that's on a barge in a river, and they take water in from the river and they put slightly warmer water back into the river. Just that's basically they're just using as the river flows past, they just warm it up a little bit. Um, Pat Patterson was telling me about that. And then there's other examples like that where so that's water, and then you've got plastics. Trying to reduce the amount of plastics, amount of garbage that's generated. They call it the circular economy. You want to have zero to landfill. There are some sites like the new Amazon headquarters is set up to be a zero to landfill. The Climate Pledge Arena in Seattle, part of their setup is to be zero landfill. And it requires quite a lot of work to get rid of all of the things that normally just get trashed. And so people are working on those things. They're not affecting sea level rise through that, but they're affecting the amount of garbage in the sea and things like that. So you can think about the whole big picture. The other thing that's important is really more about a just transition. The benefits of modern technology and the wealth of the world tend to go to a few. The problems caused by climate change and pollution tend to be disproportionately to people who are underprivileged. So there is this very specific effort around making this a just transition and trying to figure out how to not, hey, we're building a nice big power plant, but we're going to put it in the poor neighborhood, right? Because the rich neighborhood can lobby to not have it there. Those kinds of things are happening around the world, and it's getting, there's more, I wouldn't say we've stopped doing those things, but it's getting more visible and there's more pushback on them. So we're seeing that's the other part of sustainability really, is about making it a just transition so that everybody gets a better world in the future, rather than it being disproportionately for the more wealthy people in the developed nations.
Recently, I came across a New York Times article that was talking about something called tree equity, and about how rich neighborhoods actually have lower temperature during heat waves
Yeah.
because they can afford more trees, people are watering gardens, they have plants.
Yeah.
Uh,
There's a whole lot of greening data centers, greening cities where there's a lot of concrete and it gets very hot. And if you plant trees along the roads and get rid of the cars, it actually lowers the temperature of the city. Like your air conditioning doesn't have to work as well. Trees are enormously good air conditioning systems. It turns out they absorb the energy, they keep it cool, and they keep the humidity up. Yeah, so a lot of examples there as well.
so talking about the big picture, Gemma is asking, do these cloud footprint audits clash with AI foundation models that may make use of a lot of power to train models?
You have to take those into account. If you're doing very large AI modeling, you're training for Siri or Alexa or Google Voice, right? You're running some very big heavyweight jobs. Facebook runs some very big jobs too. So the large companies that are doing a lot of image classification or video classification are burning a lot of compute power, and they are buying clean energy to run it. So and trying to use more energy efficient systems. There are more specific CPUs like Trainium or the Google Tensor processor are more efficient than some of the GPUs, the standard off-the-shelf GPUs that were really designed for gaming and supercomputer type applications. So we're seeing more and more specific processor types which give you better power consumption for the energy. That there's a green, the supercomputer world has a green benchmark, the top 500 most green supercomputers based on the amount of compute they get per energy usage. So there's there's some focus on it, and it really applies a lot. The big AI systems definitely look like that. So it's a concern, but the people that are running those big systems generally are also concerned about the energy and are taking care of it pretty well.
So we seem to have run out of time for questions. I guess we can follow up on Slack, or maybe people can reach out to you, Adrian, on Mastodon or
Yep.
other types of social media. And I hope this presentation was also an opportunity for people to think about their impact and go back to their teams with new ideas and push for more sustainable initiatives in their organizations. Thank you. Thank you
Yeah,
so much.
thank you for that. Yeah, I'm Adrian CO on Twitter. I'm Adrian CO at mastodon.social. I put that link in my Twitter bio so people can find me. I still look at Twitter occasionally, but I'm posting my new content primarily on Mastodon now. And that most of the people I chat to seem to have ended up on Mastodon in the last few weeks. So that's been an interesting migration. I'm also on the Slack QCon Plus. There's a green check track channel there, track green tech. So if anyone wants to chat, I'm there as well. And I managed to join the Green Software Foundation, and that's probably the best place to go if you want your company. If you're thinking you should be doing more, you could maybe propose that you sign up to join the GSF. So,
Thank you so much,
okay,
Adrian.
thank you.
Talk to you later. Bye bye.
Cheers. Thank you. Bye.